electron, 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 electron. So you go boom, boom, boom. Let's make sure I got the count right. So 1, 2, 3, 4, 5, 6, 7. Okay. So reconstructing the atom this way allows us to see that this third shell, or this 3s and 3p, okay, constitute the third shell of the atom, okay, the third electron shell, hence the outer shell, okay? So when we think about how many valence electrons, we've got to look at that third shell. First shell can take 2 electrons. Second shell can take up to 8 electrons. Third shell can have up to 8 electrons. And that's how we'll think about it, okay? For our purposes, that's correct. All right, so chat with a partner for like 10 seconds. What are your questions? Go.
Look at that. Huh? Is that Corey? Is that Corey on the board?
Yep.
The one with the shells.
Yeah, this is chlorine here. That's chlorine. Yep. All right, so I hear questions. What are some of our questions? Kyra, question?
No, maybe I don't really have any questions.
Okay. Seraphine, questions? No questions? Joanna, questions? You don't have any questions? No one has a single question. I would love for someone to ask a question. Okay. Yeah.
Okay.
Kayla.
Like I don't really get how you can find the unpaired number of bonds or something like that.
Right.
Because like, what if the value of electrons was like 9? What would you do then?
You're not going to run into 9. You're going to run into 4, 5, 6, and 7. Okay? And so we're going to go through a bunch of examples. When you've got 7 valence electrons, one of them is unpaired. And why? The electrons only pair up when they have to. So if you want to think of it this way, you've got an element, and you've got 1, 2, 3, 4 sides. Is that okay? It's kind of like a square, right? 4 sides, okay? And the electrons don't pair until they have to. So the first 4 that go in actually go in unpaired. Then when you add an additional one, you've got your first pair, your second pair, third pair, etc. So we're going to actually go through all of the elements. So if you just memorize them or keep them in your notes, you'll be fine. But that's the way to memorize. That's the way to think about it. When you go to AP Chemistry, I'll teach you a different treatment for thinking about the way that electrons occupy what are called orbitals. And then you'll see it. You'll have a different methodology for thinking about it. But what I'm showing you is perfectly good for organic chemistry. Okay, which is what I want you to learn right now. We're actually thinking about organic chemistry this way. Okay, this is my working mental model that I use when I'm thinking about these things. I'm not thinking about the orbital fill-in diagram, which is what you'll learn in AP Chem. Okay? Cool. Other questions? Okay. So I'm going to go ahead and erase this little chlorine guy because I want to fill in more space in the table. But it's really important to see that relationship between the electron configuration and the little shell representation of the atom that we used earlier, okay, in the year. And one last thing, guys. Do electrons go around the nucleus like planets go around the sun? No, they do not, okay? They occupy things called orbitals, which have different shapes, okay? Different shapes. But the best way for you to think about all of that is that they occupy a spherical cloud around the nucleus, okay? So, next atom, okay. So we talked about diatomic gases, right? And one of them was hydrogen, fluorine, chlorine, okay? Those were 2 more. So elements ending in gen and -ine form diatomic gases. And now things are getting interesting because we're going to start talking about things that we need, more things that we need to live. So we absolutely need water to exist, but we also need to breathe a certain gas to exist. What's that thing that we breathe that helps us live? Oxygen. Okay, oxygen. So we have another diatomic gas that we're going to be able to draw. Let's figure out what's going on. Oxygen, 1s2, 2s2, 2p4. Okay, How many valence electrons, guys?
6.
2 plus 4 gives?
6.
6, okay? So 6 valence electrons. And then let's go ahead and draw this guy out. So O, and then here, Kayla. So like if you were to do this, you would go like 1, 2, 3, 4, and then you'd say, okay, 5, and you can draw it over here, you can draw it here, it doesn't matter, 6. They don't pair until they have to, okay? The electrons repel each other, they'd rather be split apart than paired up, generally speaking, okay? That's a good way for us to think about it. So number of bonds, it's got 2 unpaired electrons, so it's going to make how many bonds? 2, okay? So here are some example molecules. We drew water like this. I'm actually going to draw water in a different way. I'm going to draw water like this. And that's a good representation. Water has something called a bent molecular geometry. I'll ask you that again, but water has a bent molecular geometry. Just keep that in the back of your mind. We're going to get to it in a little bit. Now oxygen, when it binds to itself, or when it bonds to itself, right? Each oxygen atom has to make how many bonds? 2. Okay, so look, chlorine makes 1 bond, so it makes 1 bond with another chlorine. If oxygen has to make 2 bonds, how many bonds does it have to make with another oxygen?
2.
Okay, follow. So chlorine makes 1 bond, each chlorine. So when 1 chlorine bonds to another, it makes 1 bond to that other chlorine. But each oxygen needs to make 2 bonds. So if 1 oxygen bonds to another, how many bonds must they share?
2.
Okay, no joke. Like they actually have to share 2 bonds. This thing is called a double bond. Okay. So I'll show this to you in a different level of detail. Like look at O. And then it's got like an unpaired here and an unpaired there. And then you've got another O. These guys are paired. And then it's got like an unpaired here and an unpaired there. And you can see how they come together. These 2 unpaired electrons pair. These 2 unpaired electrons pair, right? And that makes both oxygens happy. Let's count the number of valence electrons that this oxygen has access to. And remember, each bond stands for how many valence electrons? 2. Let's count. Ready, set, go by 2s. 1, 2, 3. 2, 4, 8. This oxygen is just like neon. He's happy. Let's look at this one. Ready, set, go.
2, 4, 6, 8.
Also just like neon, he's happy. Okay? So that's why that molecular structure works. And we're going to leave it at that. Okay, oxygen. And now we're actually going to start having some fun. So this is when things actually get really, really fun. So this little red sphere, okay, stands for oxygen. And we're going to build him like this. We're going to put these 2 little stubby bonds, okay, these little stubby sticks in, and these little white balls represent hydrogen. We're going to stick them in right here. Okay. And these, in fact, are called ball and stick representations of molecules. So this is water, right? You need this thing to exist. 1 oxygen, 2 hydrogens. You're seeing its 3-dimensional molecular representation for the first time, right? You've never seen this before. And this is inside of you. This is allowing you to exist as you do, right? You would be done for if you got fully dehydrated, for sure, right? You can actually only live for so many weeks without, so many days without water. Yeah. Mm-hmm. You can leave weeks without food, days without water, minutes without air. Okay, so here you go, right? And then this guy over here is also very important. So 2 oxygens, and we can't use those little stubby bonds anymore. We have to use these longer, more flexible ones. So I've got 2 oxygens here, and I'm going to go ahead and bond them together like this. And this makes oxygen, okay? This is oxygen gas, and we need this in order to survive. But what's also very interesting is that in addition to hydrogen and oxygen, we also have nitrogen, okay? And his electron configuration is 1s2, 2s2, 2p3. And so he's got 5 valence electrons, and his Lewis dot structure looks like this. And he has 1, 2, 3 unpaired electrons, so he makes how many bonds? 3 bonds, okay? And so nitrogen actually is the principal component of air. And he makes 3 bonds to himself when he bonds. So 3 bonds. This is called a triple bond. And he also can bond to hydrogen. Like this. And so this guy over here is called ammonia. That's necessary for the fertilizer that is used in non-organic farming. Okay, so most of the food that we eat was fertilized, the plant food, okay, plant-based food was fertilized with that stuff. Not a great thing because it's causing dead zones in the ocean, but nonetheless, a means of producing food, something to think about. So this guy is ammonia, and what's interesting about ammonia is he's actually a triangular pyramid. So his molecular shape is called triangular pyramidal. And this drawing represents one of his bonds going back behind the board. That's this dotted line. This wedge represents a bond coming out of the board. And this solid line represents a bond in the plane of the board. Okay? So this is called a pseudo 3D drawing. And it's meant to represent this little molecule right here. Okay, this little guy. And I'll come around with him and you'll actually build him at your desk. And last order of business, nitrogen gas. So when you breathe in oxygen, 21% of the air. You also breathe in nitrogen, 78% of the air. And those nitrogen molecules, just like the oxygen molecules, fly around the room at roughly the speed of sound. So, very, very fast. And what's crazy about that is we all have been breathing each other's nitrogen molecules all year long. Like we've just been breathing in one another's nitrogen molecules without issue. And that's okay. They don't carry germs and they don't get contaminated. They are chemically inert. They don't react. At least not with us. So there are plants that have nitrogen-fixing bacteria in their roots. But we don't do any of that business. So this is nitrogen and this is oxygen. Together, they account for 99% of air. Okay? Can't live without air. This is water, right? You have to have this to live. This is ammonia. This also produces food, okay, is used to produce food, which helps you live. Those are 4 very important molecules, and today we will build all of them.